Welcome to lesson 81. We're going to look at a new one that I don't think we've seen before. These are graphing and transforming square root functions. So still in the exponential family, except we're going to talk about square roots instead. So again, we're going to look at the changes to a, h, and k when we look at the actual equation for itself. And we're going to try and figure out how it adjusts. Basically, are the shifts left to right, up, down, flipped and upside down, or vertically stretched or compressed. So, what's happening here. So let's start by just talking a little bit about what it actually looks like. And these graphs do look different. They're different than what we've seen before. And they're kind of like this. So it looks almost like it's half of a parabola. Like it's only half of it. So that's what they're going to end up looking like. And so this is going to be our base, our square root x, and what it looks like. And we're going to try and figure out what happens with a, h, and k. So we're going to start with a. And a tends to be the one that tells us, is it up or is it flipped? And it also tells us if it's stretched or compressed. So let's make some predictions. All right, so we already know what our base is going to be, and we're using our same information that we've seen in the last two. So if the coefficient a is greater than 1 in the past, it's been compressed. So we're going to see if this is still true. We're going to test this. And if it's less than 1, it's been wider, like stretched wider. And if it's negative, it flips. So let's look at an image and see if this is true. Okay, here we go. So here's our base right over here. And we got some surprises, our first surprise in a while. So basically, here's our surprise happening with whether it is a greater or less than 1. This has been reversed. So in this situation, and I'm going to X this out, it looks wider. And when we had a as less than 1, it was actually compressed. So these two flipped from what we've previously seen in multiple times. So I want us to really name that and stamp that in our minds that this is happening for the square root ones. Because it wasn't true for quadratics, it wasn't true for our absolute value. But it is true, at least for the negatives, that still remains the flip. All right, so let's hit pause and jot this down into our notes. Nice to be surprised. Let's explore H, and that had to do with our horizontal shifts. And it's interesting that we had a surprise last time, so let's see if there are any more surprises here. In our past pattern, we had anytime there was a positive H, we saw that it shifted to the left. And if it was a negative H, it shifted to the right. So positive H, negative H. So let's see if that's true and confirm it. I'm still going to hold on to what we're noticing. And here we go. Let's actually make this a little bit bigger so we can just see what's going on here. All right, here's our base. And here we have x plus 5, and it did shift to the right. To the left. And here we have x minus 5, and it shifted 5 to the right. So this is confirmed. So when there's a positive h, it shifts to the left, so it becomes a negative number. And if it's a negative h, it shifts to the right, and so our vertex will have a positive value for x. So name that. We're seeing it. We got some confirmation. Had a little bit of change last time, but everything here is exactly the same. Let's go on to our next one, which is our k. And our k represented the vertical shifts. And we saw that when k was positive, you shifted up, and when k was negative, we shifted down. So let's confirm if that's true. So this is what we're expecting, right? So we have our regular. We're expecting when it's positive, we're going to go up, and we're expecting when it's negative, it's going to go down. So let's see. Yeah, that's what happened. So we have it here. This is our square root x plus 5 in red, and it did go up 5. And here we went down 5 when we had square root x minus 5. And again, this is outside of the square root symbol, so the k is on the outside versus our base. All right, so this part is also confirmed. So where are we actually seeing shifts? So we are not seeing a change in the patterns for h or for k, but we did see a slight difference in a for square root as opposed to quadratics or absolute value. So let's get into some guided practice. Here we go. We have our parent function and we have our new function. So hit pause and identify what are the transformations, and as well as what is the new starting point. And I'm calling it a vertex. What is the new starting point in relation to f of x? Hit pause and jot this into your notes. All right, so what do we see? What do we notice? Here we have a is equal to 0.3. So we saw something different happen here, right? So what do we think that's going to mean for a? Being that is less than 1, this time it's going to do the opposite. Instead of going wider, it's going to be compressed. All right, let's see, what do we know about our h? Our h is a positive 3 in there, so that means we're going to shift 3 left. And our k has a negative 4, so because of our k, we're going to shift down 4. All right, so given that shift, our starting point, we'll go from 0, 0, left 3, and down 4 to negative 3, negative 4. Okay, and let's confirm this using our image, and here we go. Just going to put this down here for you, and you can see that is our new starting point. We are correct on that part, as well as, yes, it is more compressed, so we were correct there, and it did shift 3 to the left and down 4. So we had the other transformations. All right, Math Marvels. So again, we're just building some awareness with some new information. So use this along with your notes in order to continue to practice and just getting a sense of what you think is going to happen, these transformations. We're seeing this again and again in some patterns. I will see you in the next lesson, Math Marvels. Be well.